Astrophysicists and astronomers all over the world are celebrating a golden moment this week. The announcement of a scientific finding that has Nobel Prize written all over it. They witnessed the collision of two incredibly dense neutron stars and found a scientific holy grail in the process. It provides further proof that Albert Einstein was a genius, relatively speaking. The findings help us understand the universe better, and as a result, we now know where all the gold and silver and platinum in the world comes from. It's the focus of our Leading Edge segment this week, and science correspondent Miles O'Brien joins me now. Miles, tell me, why are they so excited about this?
It's a textbook changer, Hari. It happened in August, and it began with two observations. One of gravitational waves, ripples in space-time, if you will, followed right on its heels by the recording of a gamma-ray burst. This set off this amazing scientific full-court press that led to this discovery. The focus of all this, Hari, are neutron stars and the collision of two of them. Neutron stars are what is left over after a supernova, a star burns out. These things are the densest things we know of in the universe. These, at the focus of this story, were about the size of Boston, and yet they have a mass that is 50% greater than our sun. They're relatively rare to have two of them collide. It happens only about once every 100,000 years in our galaxy, the Milky Way, Hari.
So did we just get lucky? Did all these people just get lucky when these kind of all their beepers and bells and whistles started going off that something was afoot?
Well, luck favors the prepared scientist, I guess, in this case. It began with the LIGO instrument. This team just recently won the Nobel Prize for a discovery in 2015 of these gravitational waves, wrinkles in space-time that proved out Einstein's theory of relativity. It did that by detecting the collision of black holes. Now, in our business of television, we prefer our science illustrated. So when they discovered that there might possibly be a collision of neutron stars, that includes an explosion and some light, and that made people feel a little more excited. In August, the LIGO instrument detected one of these gravitational waves, but it was ever so slightly different. It happened a little longer because these neutron stars move a little slower than black holes. Another instrument, subsequently, the Fermi, which is an orbiting instrument, detected a gamma-ray burst. Scientists thought they were hot on the trail of one of these elusive neutron star collisions, and so they started scrambling. Ido Berger is part of the team. He's at Harvard University.
As soon as we received an alert from the LIGO instruments telling us that they detected a gravitational wave source, we started calling up observatories all over the world where we have programs that are ready to go for that purpose. We gave them the coordinates of the source on the sky where they would have to point a telescope. And as soon as they pointed a telescope in that direction, we could look at the images coming in.
Working together, the gravitational wave astronomers and the light wave astronomers were able to kind of pinpoint this location very quickly, sort of triangulate in on the galaxy where it was happening, a galaxy that is 130 million light years away. And it turns out it was much more than a light show. Once they were able to find it and they watched this explosion unfold, they were able to really record the entire electromagnetic spectrum. And in it, they were able to see the distinct signatures of all kinds of elements, including these heavy elements, gold, silver, and platinum, proving that's where that furnace, that explosion, is what creates those particular elements.
So now that we know where some of these heavy elements come from, what do scientists do with that information?
Well, it would be nice to go out and get the gold, wouldn't it, Hari? It's 130 million light years away. It's a little bit of a problem. Somebody actually calculated how much gold would have been created by this particular collision. Just so you know, it comes out to about 10 octillion dollars worth. That's 1 followed by 27 zeros. So we could quit our day jobs if we could get out there, Hari. But obviously, scientists are not as focused on the gold itself. For them, knowledge is gold. Duncan Brown is a physics professor at Syracuse University.
This really is a new type of astronomy. We're now bringing together all the tools that humans have to bear on observing the universe. We can feel the ripples in space-time. We can see the light from things colliding out there in the universe and exploding, and the light from stars. And bringing all these tools together is going to allow us to learn so much more about the universe.
You know, give me a sense of this collaboration. I mean, right now in the United States, we can't get two parties to agree on something, but you're talking about different teams from all over the world responding at the drop of a hat.
Yes, and there are cases where astronomers will line up observatories to look at events, and they collaborate on these things. But as best we can tell, this is unprecedented in its scope and its speed of response. It was really lightning fast once the word got out. About 70 observatories ultimately were pointed at this unprecedented event.
Now, all this happened just last August, but really it happened when the dinosaurs were walking around.
Yeah, it's a little bit of a mind bender. When you look at this event, 130 million light years away, it took that long for the light to reach us. So really it happened 130 million years ago. And that gives you an idea of how old the universe, and also gives you an idea of how these particles, which are created so far away, ultimately have really great meaning to us. We end up wearing them. It's bling.
Right. Miles O'Brien, thanks so much.
You're welcome, Hari.